Welcome to episode 333 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm all right, Rob. How are you doing?
Doing okay. Had to get my daughter COVID tested yesterday, so waiting on that to come back, which a little antsy about, but hopefully it'll be fine. She doesn't have any symptoms or anything, but she sat next to someone at lunch who had it, so gotta get checked.
If you, I was just following a Twitter thread this morning about all of the fake COVID testing centers around the United States.
Fake COVID testing?
Yeah, that they are charging you, or not necessarily charging you, but they're using it as a way to collect personal information, and then they're charging the government for the test, and then giving you a negative result no matter what happened. Like not even actually running a test.
That's a fun new scam.
Yeah, honestly, I'm not shocked because everyone tries to make a buck in the situation,
I guess so. That's unfortunate. How do you know to look out? Like, what do you look out for to avoid a fake COVID testing center?
Well, according to this particular Twitter thread, the thing that cued one guy off to this being fake is that he saw that the, go here to get your results was a static URL. So everyone was given the same URL.
Wow, that's terrible.
Yeah.
Okay. Well, at the top of every episode, I like to hear a piece of feedback. We got this comment on the Include C++ Discord. We do have our own group for CppCast in the Include Discord. And this comment was from OJ002 saying, latest episode, referring to the recent episode with Slobodan about his modern C book. Latest episode mentioned that there is no container vector that can accept everything without void star shenanigans. There's actually a very easy to use way of getting almost the exact behavior of std vector in C using macros. And he has a little code snippet here pointing to this stretchy buffer library. So I will put a link to that in the show notes. And he actually goes on to say that he made his own version of this container library, and there's some other neat things. He also talked about some of the proposals going into C2X, like lambdas, and you can go and read them with a link he put here. So thank you for all that.
It's kind of scary. I mean, just in theory.
Kind of scary doing all this with macros, but is that what you mean?
I don't know. I feel like I need to look at it and see what it's doing.
Yeah. Well, the second link that this person put in is like a more type-safe version of this container library.
Okay.
They said, yeah.
Cool.
Yeah. Well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Marit Tokle. Marit is a senior software engineer working with secure development and application security at Sopra Steria, Norway. She's engaged in the hacking community in Norway, among other things. She is a member of the CTF team Bootplug and a board member of the Association Oslo CTF that focuses on creating an inclusive and safe learning environment for beginners in security. Marit, welcome to the show.
Thank you.
I really, really want to ask you about the CTF team stuff, but we're going to have to wait for later. Because but it's just the thing that I want to latch on to with your bio. Like, anyhow, I'm so curious. We'll talk about that more though.
Yeah.
Also joining us today is Christian Ressell. Christian is a security engineer working with tracking and analyzing APT actors. He has previously worked with vulnerability research and malware analysis. He is a CTF player and regularly solves challenges related to binary exploitation for his team, Bootplug. Christian, welcome to the show.
Thanks.
Okay, so we'll talk about CTF later, but you added another acronym or initialism in here, APT. What are APT actors?
Yeah, so APT is short for Advanced Persistent Threat, and it's usually used to categorize like hacking groups that are state-sponsored or that has significant funding or backing of some sorts. So yeah.
Very interesting.
So you track and analyze those people.
Yeah. So I kind of have to look up, check what they're doing and see if they're trying to abuse any of our systems and to protect users from attacks, basically.
Okay. So like, it's like a normal day at the office, like, North Korea's hacking our system again.
I guess unfortunately, like sometimes it is like that. You kind of get numb to it, I guess. There's a lot of attacks happening all the time. And before I used to work for the Norwegian CERT, which is another acronym, which is short for Computer Emergency Response Team.
Okay.
And there as well, you kind of see everything that hits, the Norwegian government directly, or critical infrastructure, and it's just a lot of stuff happening all the time. So yeah.
So that CERT, that's what a lot of our listeners would maybe already be familiar with for like software vulnerabilities, that kind of thing.
Sorry, what was the question?
For like security vulnerabilities in like a library or something, when there's like a notice posted about that, a cert, like, is that the same CERT thing, or are you?
No. So this is like a team that's embedded for the, or I guess it's a team that works. It's the whole team that does like incident response and responding to threats and attacks. And
but don't they also like post vulnerabilities that we need to fix, like, hey, there's something we need to fix now?
That's what I'm familiar with seeing CERT.
Yeah, that's actually a good point. Maybe I'm not actually sure. It's been a while since I worked with this. Yeah.
Okay.
Well, we got a couple news articles to discuss. Feel free to comment on any of these, and we'll start talking more about binary exploitation and CTFs, okay? All right. So this first article we have is year, month, date, hour, minute, just overflowed assigned 32-bit int. And this is just a really short post about how, in January 1st, 2022, if you're using assigned 32-bit int to store dates in this format, doesn't fit anymore. And I never really thought that this would be used to store dates in a 32-bit int. I'm not sure how common this was, but I certainly was not expecting that this January 1st would be like a Y2K type scenario for some software systems.
I have so many questions about this. First of all, why is it a 2-year? Why is it a 2-digit year?
Mm-hmm.
Didn't we learn that lesson approximately 24
Didn't we
years
learn
ago?
that? Yeah.
Apparently, for some people, their Exchange servers stopped working. But it was not Exchange specifically. It's Microsoft's vulnerability scanner that plugs into Exchange that started to dying. If you click on the really no joke link on this one, it's the...
That's what that points to.
Microsoft scan engine failed to load. So the Microsoft vulnerability scan engine for emails. So they had to people who had this problem had to turn off virus scanning on Exchange to be able to send email.
Wow.
Yeah, that's weird. I was thinking if this could be used, it's integer overflow, right? And while thinking about it, it wasn't that interesting, from an exploitation point of view, because I don't think I could exploit it. I don't know, Christian, would you be able to?
I guess in this case, you're forced to turn off your, defense mechanism. So, but I guess other than that, causing unexpected behavior, I don't know for this case. But it's a funny bug, at least.
Yeah.
It's definitely a funny bug. I also just thought we were past these things after Y2K. Is the the Unix epoch still something we need to worry about in 10 years, or is that
Y2038?
Yeah. Anyone know?
I believe it's still an issue on some systems, because if you're still using a 32-bit timestamp, and some of the Unix system APIs still use 32-bit timestamps, it'll overflow. Yes, I believe it is still a potentially lingering issue.
Did you say it was 38 when that would overflow, or was it 34?
I thought it was 38, but
that's what I thought as well.
Okay. Well, 16 years. Hopefully, you can figure it out before that.
And no, I think it's fine. In 15 years, when everyone's panicking, we all just become very highly paid consultants fixing these issues.
There you go.
just like all the COBOL programmers did in Y2K.
Yeah.
Yeah, sounds great.
All right. Next thing we have, this is just a really short Reddit post, but interesting that the James Webb Space Telescope, which there's been some news about recently, is running C++ code. So that was cool to hear.
Yeah, I hope they do their memory management well. Yeah. I mean, space shuttles, they should be secure, right?
Mm-hmm.
Mm-hmm.
I think with a lot of the systems, they're not allowed to do any dynamic allocation at runtime at all. Like it's all front-loaded kind of things, so that eliminates some classes of bugs.
Yeah.
Did you all read the comment thread?
I skimmed through some of it. Was there something you wanted to highlight there?
Well, I just felt confused by it because all of the top-rated comments are complaining about how the comment section is full of people complaining about C++, but I couldn't actually find any comments about people complaining about C++.
Are they referring to YouTube comments?
I don't know.
I did not see the comments complaining about the programming language, but I did see the top ones. And but that is one of the things that we do say when we talk about binary exploitation, that not using memory unsafe languages is kind of a way to avoid vulnerabilities, right? But that's a huge discussion.
Although, I think I have maybe a simple question. What languages are considered memory safe languages?
Well, we do have Java, Python, but then again, Python is written in C. So there was, I don't remember when it was, like last year or something, there was a vulnerability found in Python, so that Python was had a memory vulnerability, even though it's a memory safe language.
Yeah, it was like using C APIs behind the scenes in an unsafe way. So in that way, you kind of, you can get some issues. And we kind of have the same in JavaScript as well. So, every, modern browser today is, parsing JavaScript. And the JavaScript engine is always written in, I think all the modern browsers are using C++.
I believe so.
Mm-hmm.
But there has been a ton of issues in the engines. So, but I guess the language in itself is memory safe, but the implementation might not be. So I guess it's,
I feel like there was an era around, 2009, early 2000s, if you will, where every single vulnerability that I saw was a new one in the Java JRE and Sun's JRE. And you're like, crap, I have to update my Java runtime again. I thought that was the whole point of using Java. I haven't seen that come up in a long time, though. Maybe they've resolved those.
Yeah,
that's a good point.
But we did also mention Rust, and Rust does have some of these capabilities, like you can create kernel modules, right? And so they can still be pretty fast when we talk about the security versus performance issue. So that can be a good option as a memory safe language.
So as security researchers, if you find out that a project was written in Rust, are you more likely to say, oh, well, it's going to be harder to find a vulnerability here?
You can still do unsafe things in Rust too. You just need to do it explicitly, right?
Yeah.
So I think if you want to look for memory safety issues, it's a lot harder in Rust. I mean, you would have to look for these unsafe, where the programmer explicitly uses unsafe code.
Okay.
But I mean, you still have this all these other classes of bugs, like logic bugs and so on. Yeah. So I mean, you would just have to kind of change your mindset a bit. So you're not looking for, I don't know, string copy or some other pattern like that. You have to look for other types of patterns.
Okay.
And then this last thing we have is a post on Rainier Grimm's blog. And this is my mentoring program, Fundamentals for C++ Professionals. And I don't think we mentioned this before, but it looks like he's setting up this like new mentoring class. I'm not seeing like how to register for it. Maybe he's just kind of putting this idea out there that he's going to be setting up this class, but certainly seems like something that some of our listeners might be interested in.
I did actually read this whole article. So to answer your first question, he says that the registration will open, what did he say, 4 weeks before the class goes live, which he's planning for April. Goals to launch the course in April. And Rennie, yes, wants to open registration 4 weeks before the course starts. Right.
Okay.
So it's going to be a 9-month course. And if you want to go to the website and see, there's 28 topics that will be covered. And each week you'll get videos and access to his books.
And also one-on-one mentoring, which sounds great.
And for people who are curious, it's €250 per month.
Okay.
Seems like an interesting concept. I'll be very curious to see how it goes for him.
Yeah.
Kind of want to sign up, actually.
Well, if it goes well for him, you could look into doing the same type of thing yourself, Jason. So
yeah,
you don't like the online training much.
Well, I don't love online training, but that seems kind of, I don't know. Reiner came up with this great idea. Now I'm going to steal it.
Yeah, that's true.
I hope it goes well for Reiner, and I will continue pursuing the things that I'm pursuing.
Yeah. All right. So let's get started talking about vulnerabilities and security research. How did you both get involved in this space?
You want to start, Marit?
Oh, I was going to let you start, but I can. My answer is meeting Christian, really. So I hoped he could do like an introduction first. But when I met Christian, that was basically when I became a nerd. I didn't really have a community or anything before I met him that really like found all these tools that are cool to use and makes us do efficient programming and hacking and whatnot. So meeting him, and he introduced me to this Norwegian hacking competition called TG Hack. And I became a part of that community, making challenges there. That was how I came into the security community. But I'm not actually doing security research, though. That's what Christian do. I do like security development, but I do hacking on the side, like after work. Yeah.
Well, you said it was after you met Christian that you became a nerd, but so then I have to ask, what were you doing before you met Christian? Like, were you already a programmer?
Yeah, I did go to the university with programming for 4 years before I met Christian. But then I was hanging out with a lot of people, going out, getting drunk a lot, only doing like whatever we had to do to pass. So it's just amazing that I even passed, but it was barely. Yeah.
So you were a partier and then you became a nerd.
Yeah. But I was always a nerd within. I just didn't have the people to be nerding with. Yeah, totally.
Okay, how about you, Christian? How did you get involved in this?
Yeah, I think it all started like way back when I was a kid. I was, playing my Nintendo 64 and stuff. And when I kind of got tired of the game, me and my friends would always be looking for like glitches and bugs in the game. To just mess with the game basically. And like during that period, I was always like interested in computers. My dad is a programmer. So, we always had a computer around, but yeah. And for some reason, I thought like hacking was a bit interesting. Can't remember like the first time I, was made aware of it. But basically, I did, I tried to learn programming several times, but I always like gave up because it was too boring or too hard. I was like, screw this. So it wasn't until I started the university that my kind of interest picked up again. And that's where I kind of learned all of this security stuff. Once I kind of got over that barrier of, I was able to write more than, hello world. in Java. I was suddenly, I got super interested and started digging into low-level stuff like C and assembly, and that eventually led to this security stuff.
I mean, in all fairness, though, Hello World in Java is like 15 lines, so it's not nothing.
I was working as a teaching assistant in our Java course at the university, and like the first thing we always told the students was like, yeah, don't think about all of these lines of code. It's just there, just forget it. Yeah.
So you said you got started by trying to exploit games in your N64. So just out of curiosity, like I've been watching some of these speedrunning videos lately, and now they're like, "Oh, we just cracked level 3 of Mario Kart 64 finally," and like finding the bug that lets them speedrun that level on Mario Kart. Like, do you follow any of that stuff?
Yeah, we're
Today?
actually watching.
Yeah.
Yeah, yeah, we're watching a marathon right now called Games Done Quick, where they collect it's like a charity event where they get money, and now it's for the Prevent Cancer Foundation, and it's just like speedrunning for a week straight.
Last year they did have this really fun bug where they flipped a bit what was that? Was it like a satellite thingy where they managed to flip a bit and then do you remember?
Oh yeah.
Yeah, and then they could do this really weird glitch in the game.
Yeah, what was it? It was something like super crazy, like some like disturbance, like I'm not sure what it's called, like electromagnetic disturbance or whatever, flipped a bit in memory on his console,
wow.
and that enabled him to do something weird. It was like it's like the weirdest stuff I've heard about.
You start aiming microwave magnetrons at your N64 so that you can actually.
Oh,
God. Very interesting. So we already talked a little bit about, memory safety and things like that. Do you want to tell us what exactly binary exploitations are and some of these topics you went over in your NDC Techtown talk?
Yeah, sure. So binary exploitation this is when I always say it is to exploit binaries, which is like obviously, but it's to exploit vulnerabilities in binaries. And these vulnerabilities are often memory safety issues. So we already talked a little bit about overflows, and it's common with like stack overflows or buffer overflows. And we also have this one type of overflow called Heap Overflow, which is very common, and that's the one we talk about in our talk. I don't know. Do you want to fill in, Christian? Is there anything more we should?
I think that's a good introduction. We just want to, mess with binaries in some way or another, and memory safety is like I guess it's one of those classes of bugs that are, prevalent still today and has been for a long time, and they're usually very, very powerful.
Yeah. For our talk, we tried to find some statistics to let everyone know how relevant it is. And I was actually quite surprised. I didn't really think that it would be more than half of the vulnerabilities that both Google and Microsoft found. They were memory safety issues. And that was surprising for me, at least. I mean, when I'm doing development with my development teams, if we at some point, and we rarely do, talk about binary exploitation, someone will always say that it's old news. That's probably not relevant anymore, but obviously that's wrong.
I just imagining someone on your team telling you, since this is the kind of thing that you do, oh, that's old news. Like, really?
No. Most of my teams are really, really cool. But it's like, I just never knew how relevant it was myself. And I kind of got fooled by these comments, like it's probably not relevant. And while doing this easy and really actually old easy buffer overflow challenges, I've always thought that this is probably not that relevant or common. But yeah, we still see some I guess at least Christian, you see some like simple buffer overflows here and there.
Yeah, like especially in like embedded systems, like simple Stack Overflow can still be like relevant, even though it's not in like I don't know, modern software.
Mhm.
It's not really that big of an issue anymore. But some products, they just disable all kinds of security mechanisms, or they in some cases, like the security mitigations and mechanisms aren't available especially if you're like on embedded or something like that. Like if you're writing software for I don't know, like a remote control for your TV or something weird, it's like, yeah.
I think almost all programmers have probably experienced a Stack Overflow when writing a recursive function, whether they did it intentionally or not. But
Right.
can you explain what a heap overflow is, since that's what you started this conversation with?
Yeah, Heap Overflow is more or less the same as a Stack Overflow, but we have the static memory allocation and then we have dynamic memory allocation. And when we do static memory allocation, we allocate on the stack, while dynamic allocation is on the heap. And so whenever we allocate something runtime, we do heap allocation.
Okay.
If that's correct.
Yeah,
Yeah.
Sounds right.
like
Sounds
in
like
C++. Yeah, sorry.
Yeah, go on.
Yeah, so in C++, like whenever you do new some object, that's a heap allocation.
Okay.
And like behind the scenes, and if you have something like if you're writing to a buffer allocated with like new or a malloc or whatever, and you're writing too much data into that buffer, that's a heap overflow.
Okay, so if you like write past the end of your buffer, that's a
Yeah.
heap overflow.
Hmm.
Yeah,
Is that
correct.
the same thing as a buffer overflow then, or not?
It's kind of the same. It's just a
Yeah,
different type of storage.
Okay.
I think like buffer overflow is like a, I don't know, umbrella term kind of, and then you can be more specific and say, oh, this is a stack overflow or a heap overflow, or like sometimes you have a global buffer overflow. So yeah.
So if the buffer lives on the stack, then you might get a stack overflow. If the buffer lives on the heap, you might get a heap overflow. Okay. All right, cool.
Okay.
Thank you.
So, do you want to tell us a little bit about the specific hack that you showed in your, NDC talk? Because it was, pretty interesting.
I'll let you do that, Christian.
Okay, sure. Yeah. So we tried to demonstrate a bug that was found by a company called Qualys in sudo. So we chose this because like sudo is such a common tool. I mean,
that's the Unix escalation, privilege escalation tool or whatever. Okay.
Yeah. So yeah, I mean, sudo is in basically every Linux distribution, and used to get higher privileges to install packages or whatever you might need to do on your system. And this was a heap overflow in this program that they found, and it enables like a local attacker to take full control of the machine, even though you're not allowed to use sudo. So you can be like a totally unprivileged user, and suddenly you have full control of the system because you kind of tricked sudo into giving you more privileges.
That sounds
Without
bad.
even writing your password, right? That's scary.
Yeah, you don't have to do anything basically. You trick sudo. Like the bug is so early on in the code, so it doesn't have time to check your password or check if you're a legit user or anything. It's just basically you have full control very early on, and that's what makes it such a I don't know, bad bug, I guess.
How recently was this bug discovered or exploited? Or
it was Isn't it like a year? It's almost an anniversary, I think. Yeah.
Wow. So surely these things aren't relevant anymore, right? Like
So obviously we don't have the ability to look through code right now like you did in your talk, but can you talk us through exactly how this pseudo hack works?
Okay, I can try to kind of
Do your best, I guess. Yeah.
simplify it. Yeah.
It's hard without the code.
Yeah.
So basically, there's this one mode where sudo parses command line arguments. And one thing it has to look at is like escape characters and stuff like that. And what sudo does is like early on in the code, it checks basically how many command line arguments do we have. And then it allocates space for all of these command line arguments on the heap using malloc. And then there's like this weird bug where if you enable some flag when you start sudo, it changes how it parses these escape characters. And then like later in the code, like this buffer has been allocated, there's room for all the command line arguments, and now we're going to copy them from one place to another. And so basically what it ends up doing is like, I think it places like a space between every command line argument and puts them in a like huge buffer. And the problem is that if you end your command line argument with a backslash, sudo will increment past the backslash, and then in C, like every string is null terminated, and then it will kind of skip the null terminator and keep like reading out of bounds of this buffer. And if it finds more valid characters, all of those will be copied into this heap buffer, and that ends up overflowing the buffer, like you're writing outside the bounds. And yeah, and again, then you can use this to kind of manipulate data on the heap to trick sudo into basically running your code.
I've written almost exactly that same bug.
Yeah, it's
Nice.
hard to get it right? That's
Yeah.
It also shows, the bug shows how important it is to write a readable code, because that exact piece of code wasn't really easy to read. At least in my opinion, it wasn't.
I agree. I think we also got some questions during one of our presentations where someone was asking like, what is going on here? This code isn't valid or something like that. Because it was doing some weird assignment and checking, and yeah, it was...
It's C, it's probably valid.
So as Jason said, he's probably written this exact same bug.
I've come very close to it. I mean, I can
have, yeah.
Yeah.
What kind of tools or patterns might you recommend to avoid these sorts of bugs? Hey.
Well, at first I want to point out that we don't do much, or we're not C++ developers. Sure. But for the talk, we wanted to find more tools to be more helpful. But we didn't really have much time to do much research on it. But we do have some like common suggestions. So, for instance, like I'm more from the secure development side. So I would say like tools that we developers can use are stuff like IDE plugins or commit hooks, or when we merge our pull requests, have pull request checks. And for those, it can be like anything like very quick scans, like common security issues that just take the low-hanging fruits. And then maybe once a week, you have a large scan doing more in-depth checks on the systems. But I think Christian has some tools that he recommends as well.
Yeah, so I have some tools. But basically, anything you can do to kind of increase the quality of your code will kind of, security issues are just bugs, right? Except that they can have, have a lot of consequence if your program is like exposed to the internet or has a lot of users. So yeah, anything that increases code quality is a good bet. But like specifically for like memory safety issues and stuff like that, I always use address sanitizer when I develop C or C++. It makes it so much easier to catch these memory safety issues early on. And it also catches like memory leaks and stuff that won't really lead to security issues, but can still be good to catch these. So I think this is available in both Clang and GCC. I'm not really familiar with like Mac OS and Windows.
Visual Studio just now has address sanitizer support also. Just go ahead and mention that.
Oh, awesome. Yeah, it's really cool. And Clang also has another tool that I like to use called libfuzzer.
Okay.
So I'm not sure if everyone is familiar with fuzzing, but it's basically, throw random stuff at your program or functions and see how it behaves. And of course, there's a lot of like smartness behind like how the fuzzing is done and so on. So, but like with libfuzzer, if you have some function that kind of parses data from the user, it's very nice, and it helps you kind of catch all sorts of edge cases. So this together with address sanitizer will be like you're quickly able to catch bugs.
So do you think if libfuzzer had been run on the command line arguments for sudo, it would have found this exploit or identified that there was a bug there?
That's a good question, actually.
Didn't you say that they did use a fuzzer to find this, or did they find out about it first and then?
Yeah, they didn't use a fuzzer
code
to find.
Review, and then they fuzzed to find this feng shui. What is it called again?
Yeah, heap feng shui.
Heap feng shui. Yeah.
That's what. Yeah.
Yeah, go ahead.
Yeah, that's what, like, when you're doing vulnerability research and you're trying to like shape the heap to look just how you want it, so you can overflow, the correct object on the heap. We call it heap feng shui. It's kind of funny.
So you actually have to set up the heap in a certain way so that when the overflow occurs, you're now executing the code you want to be executing.
Yeah. So this is like anyone who does like exploit development or vulnerability research, they usually have to, like, one of the things you have to understand is like how the heap allocator or implementation works. So and this like varies a lot. Like there's one in Android user space, there's one in the kernel, one in the browser, there's a different one on Windows, on Mac, and everyone like works a bit differently. So yeah.
So maybe if I can like flip that question around a little bit that we just asked, are there tools that you use other than fuzzers and to find vulnerabilities that we as programmers could run on our own code first before we, release it over to you to find the vulnerabilities?
I have a very good example. You did use the CodeQL, right? That was a nice tool for scanning the code.
CodeQL?
Yeah, CodeQL is it's really nice. It's from GitHub Security Lab or something.
I don't think I'm familiar with
heard of that.
Well.
Yeah.
It's like a query language for code. So it compiles your code and then you can do queries on top of it. But you don't have to understand like the language and stuff to use it. You can just run your code through like different checks.
Oh, and it seems that LGTM uses that also, which I'm familiar with as a online scanning tool.
Oh, yeah. Yep.
Okay. LGTM's tied into this. Interesting. Okay.
I had not heard of this before. CodeQL. We'll put a link to this in the show notes.
Yeah. Another tool that I always use, like how I found my first bug, was grep string copy. That's always,
But that's
just kind of sad.
Yeah.
But it is recommended. When I did like pen tester training to learn a little more about how we like the difference between coding until doing pen testing, I was trying to find like the good midway on how much should the developer learn about hacking. And then when I learned about pen testing, they said using grep is a very good way to find vulnerabilities.
That's just amazing. I mean, you do mean literally the C function strcpy, right?
Yeah.
That's I mean, I don't know. It feels like we could have learned something over the last 50 years that would no longer be a reliable way of finding bugs.
Do
But that's
compilers
why-
like warn you on using stir copy without the like safer version of it?
Clang Tidy will warn you.
Clang
if you
Tidy
use the
does?
unsafe
Okay.
version
Oh,
of stir
okay.
copy. Yes.
There's actually, I think I'm not sure if it's the default, but at least on like some compilers will change string copy into like the fortified version, I think it's called.
Okay.
So it will turn into it's called string copy _ check instead, and this will actually check if it's possible to determine the size of the destination buffer. The compiler will actually, or at runtime, it will kind of check if this is the same. But in like I was looking at some firmware for a router recently, and they love parsing, HTTP requests in C using like all of these wonderful string functions. So like you still see it today, like in use. So yeah.
But that's what I mean by these IDE plugins or commit hooks. These will take all this stupid stuff, right?
Right.
And that's why, and you have this really quick feedback loop. So you don't have to wait until that long before you find these small things that you can avoid.
So I'm curious, what kind of development do you do right now, Marit? You said you don't do C++, but I'm just curious what you're...
I just started doing F#.
Oh, interesting.
Okay. So my team is huge fans of F#, but we've done some Python scripting. We do a lot of different stuff, but they are in love with F#.
So F# managed language on the .NET runtime, right?
Functional. Yeah.
Functional. Yeah. Do you have what kind of security concerns do you find when you're working on F# code, or do you?
Oh wow. I never actually. It's been like I've done it for a week now, so I haven't. I have been working more with like katas, code katas, and understanding the code more than I've been focusing on the security part of it.
Okay.
Yeah.
Well, you'll have to come back and report back at some point.
Yeah.
Yeah, I am curious what other managed languages still have to deal with. Yeah.
Yeah.
So in both your bios, we mentioned that you're both involved with CTF teams. Do we want to talk about that a little bit? Can one of you tell us what CTFs are?
Yeah. CTF stands for Capture the Flag. So the main goal of every challenge in a CTF is to find a flag. And every CTF has a wide range of categories that are usually security related. So it can be like cryptography, web applications, forensics, binary exploitation, which we've been talking about. There's so much. And every category has a set of challenges in which have different difficulties. And if you solve a challenge, you find this flag. And a flag is just a piece of string, which has a static part and then a part that is dynamic depending on, or different for every challenge. And this flag represents information you're not supposed to see or access you're not supposed to have. So if you find a flag, you kind of hacked the challenge or web application, whatever it is, you did it correctly. And then you put the flag into a platform and you get points. And so it's really rewarding in a sense, but also we've experienced that it's not for those who doesn't really have much patience. So that is probably why Christian is so much better than me in CTFs, because I don't have the patience. sitting with a challenge for 3 days, it's really hard.
But you are both on the same team?
Yeah.
Okay.
These take days to complete some of these challenges?
Yeah. So the hardest ones are like super brutal. I remember like we were playing a CTF called Defcon Ctf, which is it's connected to the huge security conference that's hosted in Las Vegas every year.
Right.
And there, I think we spent on one challenge, we were just trying to figure out how it works for like 2 days straight or something. And then when we finally figured it out, the challenge was over and we didn't get to, exploit it. So it can be frustrating at times, but it's very like rewarding once you solve something, you figure something out.
So these are specially crafted challenges, right? These aren't like, you're not like trying to hack Chrome or something like that. Is that correct?
Yeah, usually they're crafted, but we do have, like, we see more. There's at least one CTF where the challenges are like real targets, and I think we've seen
next week, isn't it?
Oh yeah, it's actually called
Real
one.
And they actually, I'm not sure if it's true, but I heard that they make people burn like 0 days or other bugs or exploits that they didn't have from before, and then someone might even use those themselves. So they take exploits and use them. Yeah, that's the rumor at least. But, yeah.
Yeah, but it's kind of funny also. Certain CTFs have like, they've found like real vulnerabilities that aren't maybe that critical, and then like you have to find the same vulnerability during the CTF, even though it's like so it's a completely real product and there's a real vulnerability. But the way the challenge is crafted makes it so that you'll have like a higher chance of finding it as well.
Have you heard about Hack the Box? Is that common to know about the
Hack the Box? I believe I have heard about that, but go ahead and explain.
So Hack the Box is a platform where they have machines where you try to first get some user access and then get higher privilege and get the root of the machine. And then often we have this like discussion between the Hack the Box people, which are usually pen testers, and the CTF people, which some of them are the same people, or some of us do both. But then there's this discussion of which one is best. Like, is it best to do the pen testing, scanning the machine, finding all the open ports, and owning a machine, or is it best to do these CTF challenges? I find it very nice to explain what CTF is, to explain this little discussion, because in CTFs, we have more like tiny pieces of problems. Someone crafted a problem, and you need to really, really understand the whole environment to be able to exploit this specific vulnerability. While in Hack the Box, you do a lot of like scanning, and it's a more bigger environment, but you don't necessarily have to have understand the environment that much, because you can often use exploits that others made once you find a vulnerability. So yeah, it's a bit of both worlds. It's nice in my opinion, but
that makes sense.
Yeah.
So there's prize money or anything like this in the Capture the Flag competitions?
Yeah, there is some. It depends on the like the contest. Like some of them have higher prize money than others. But yeah, like most of the stuff that we've won is like vouchers for Hack the Box, or swag, or I think one of our team members just got like a PlayStation 5 in the mail or something like that.
Ooh,
so
That's pretty nice.
That's worth like $2,000, right? On the black market right now.
yeah.
Yeah.
But there are some really hefty prices as well. But the thing is that there usually isn't any size limit on the CTF teams. So our team is relatively small. We usually have at the most 7 to 10 players. But the biggest teams who win a lot, they can have up to 200 players.
Oh, wow.
So if there is a huge prize, we basically have no chance.
Right.
But we're doing really good though in the world. Yeah.
Is there any overlap in their CTF world and in the community that you know with people who also participate in like the paid bug bounty kind of things, like, you know, find a vulnerability in Chrome and earn X number of dollars or whatever kind of thing?
Yeah, there's definitely overlap there. I think especially in the web application security space, I think I've seen a lot of CTF players who find a lot of like really cool bugs in different applications. I think there was like on in GitLab just recently there was one CTF player who found like a very critical bug. So yeah, there's definitely overlap.
So the kind of thing someone could make a living doing if they were properly motivated?
Yeah. I heard some of the biggest teams having like the most experienced, skilled players in the CTF community. They do get a lot. They win so much a year that they can live off it. But I mean, It's not really... I would rather have a job paying me something every month than relying on finding something.
Yeah,
there's plenty of people who'd rather not have a job too.
Yeah.
There's also this like market, I think we call it the gray market, where people like find bugs in. I guess in this market it's more popular with like you find bugs in the Linux kernel, you find bugs in Chrome, Firefox, like Windows, the iPhone or stuff like that.
And
people sell
so
these.
Much.
Yeah, these are worth like, I don't know, hundreds of thousands of dollars. Sometimes like, I think it was like one company who was paying like $2 million if you can hack a phone. But like this has become like so super hard. So I'm not sure how many people actually do it anymore. I think it was more common before. Like you could, grep string copy and find a bug and, get some cash. But like these days, it's a bit harder.
Well, there's definitely still a market for it. Like we started at the top of this. I asked you if, North Korea trying to penetrate your network is a just another day at the office. There's certainly like state actors and stuff that are willing to pay lots of money to discover these vulnerabilities, right? Not that I'm suggesting that our listeners should find vulnerabilities in Linux kernel and sell them to North Korea, just for the record. I'm just saying there's clearly a market and money for these things out there.
Yeah, I'm not sure if you saw the NSO group stuff that was just in the media, or I guess it's a little while ago. It's one of these like surveillance vendors that sell basically hacking tools for mobile phones. And it turned out that they were basically selling it to, a bunch of sketchy places.
I'm sure.
So it was being like used for human rights abuses, stuff like that. So it is like it's a weird market, and it's a lot of controversy there as well.
Yeah. Every now and then I'll see reports from someone that's like, I discovered this critical vulnerability. I reported it to Apple. They refused to acknowledge it. So I followed the like 90-day rules or whatever. And so now I'm releasing it to the public. And then Apple's like, what? But I mean, we were going to do something about that. Like, well, you missed your window.
Yeah. There's so much of those things as well. We have this scary, or in Norwegian, I would say scary story. Like, I'm not sure what that translates to, but whatever. It's this 13-year-old kid. He finds a vulnerability in his school system, and his school doesn't take him seriously. So after a while, after trying to make them listen, he writes an email or a message to the whole school, pretending to be the principal, saying something like, our security suck balls, or something like that. And then the police came to his door, took his computer, It's just crazy. So this
Oh, wow.
kid, they just took his computer. Like, if he's doing this stuff, he's probably in love with his computer. And they
Yeah.
took it, and I think they give him some sort of punishment or something?
Probably.
Yeah, probably.
I think so, yeah. I can't remember what it was, but it was kind of like they were taking it very seriously.
Yeah, but in the end, he ended up paying, or with someone else, use another really hefty tool to do some really bad shit. And then I would say that how the police did take this or handle this made him a criminal, kind of. So it's scary how handling a report, security report, is really important for, what's the correct word?
Definitely makes sense to just, do the bug bounty program, reward these people who are finding things and letting you know about it. Don't, make them into criminals. Yeah.
We're kind of running low on time here, but there's a related story where a reporter in Missouri discovered that the state Missouri system, if you were to right click on a page where you search for teachers,
view source,
do view source, it would show you personally identifying information. They reported it to the state of Missouri, and that reporter is now probably facing prosecution for hacking.
What?
Oh my god,
crazy.
really?
I've seen this on Twitter. I've seen it,
Yes.
but
It is
I
an
never
actual
thought
real
it.
thing that's happening, yes.
That's crazy. I did not think it would go this far.
It all comes down to it would seem that the governor of the state or the mayor of the city or whoever it is it's happening, I think it's the governor of Missouri, is now somehow decided he's going to take it personally. I like it, because otherwise it doesn't make any sense at all. It doesn't make any sense.
Anyone with a browser can do that.
Yeah.
So we are wrapping up, but I did want to ask, if listeners want to get involved in, learning more about exploitations, maybe getting into CTFs, do you have any recommended place where they could go, to get started in this type of community?
Yeah, definitely. Hack the Box is a nice place to start learning more about pen testing for CTFs. We do have this page called CTF. CTFtime.org. Yeah, in which there are CTFs every week, even several every week. But there are also some places for beginners. A platform called CppCast is really nice, and another one called CTF Learn. Those are nice places.
Very cool. Definitely.
Interestingly,
in the show notes.
Over the wire as well.
Yeah.
I also just noticed Code QL, because I still had that tab open from our conversation earlier, has a CTF listed on their page at the moment as well.
Yeah, that's I actually did a couple of those, and it's really nice if you want to learn Code QL. It's a good way to kind of force yourself into learning how it works.
All right. Well, Marit and Christian, it was great having you on the show today. Thank you so much for coming on.
Thanks for having us.
Thanks.